Hi everyone, welcome to our video lesson on 8-4. We're talking about rectangles today. So let's first define what a rectangle is. A rectangle is a parallelogram with 4 right angles. So we've talked about parallelograms the past couple days. Parallelograms have 6 properties to them. Rectangles also have those exact 6 properties. It just gets more specific. Now we're also talking about a shape that has 4 right angles. You've probably known that at a very young age before, but now we're fully defining it. It's a parallelogram, so opposite sides congruent, opposite angles congruent, opposite sides parallel, the diagonals bisect each other, one diagonal creates 2 congruent triangles. All 6 of those properties still exist, but now it also has 4 right angles, or 4 90-degree angles. Another big property about a rectangle, this conditional statement, this if-then statement, if a parallelogram is a rectangle, then the diagonals are congruent. So the distance here from point A to point C, let's say that distance is 3 feet long. The distance from point D to point B, that diagonal, is also 3 feet long. So in a rectangle, the diagonals are the exact same size. One thing that's kind of also interesting about rectangles with the diagonals here, if you know one measure, you know all of the angle measures. Let's just break this down for a second. If this is 20 degrees, I don't know what it is, but let's just say it's a 20-degree angle right there. Because angle C is 90, now you know this one has to be 70, because 20 plus 70 makes that 90-degree angle. Now, because a rectangle is a parallelogram, the diagonals bisect each other. So this point right here, this intersection, I'll call it point E. The distance from A to E is the same distance as the point from C to E, because the diagonals bisect each other. And because the diagonals are also congruent, the distance from B to E is also the same distance from D to E. So all 4, A to E, B to E, C to E, and D to E, all 4 of those segments are the exact same size. So now that we know that, this triangle that I'm highlighting in blue is an isosceles triangle, right? Because 2 of the sides are congruent. So in an isosceles triangle, the base angles are congruent. So that means this one has to be 20, and this angle D is right, so this one has to be 70. And now we keep on going. A, E, D is also isosceles, so this one has to be 70 because the base angles are congruent, meaning this one has to be 20. And we have another isosceles triangle right here, so the base angles are both congruent, they're both 20, and that means this one has to be 70. So all we're missing is 4 angles, and it's the angles that have E as the vertex of that angle. So how many degrees is this one right here? Well, this one's 70 and this one's 70. That makes 140. In a triangle, there's 180 degrees, so that means this one has to be 40, because 140 plus 40 makes 180. This angle over here is vertical to it. Vertical angles are congruent, so this one has to be 40. And then finally, this angle right here forms a linear pair with this 40 right here, so this one has to be 140. Or you could say in this triangle there has to be 180 degrees. If this one is 20, this one is 20, 20 plus 20 is 40. We need an extra 140 degrees for a 180 degree triangle. And then this angle is vertical to it, so it's also 140. Woo! If you know one angle, you know them all. Crazy, crazy. All right, let's take a look at this one. It says find x. We know that the distance or segment AC is 6x plus 4. And we know that BD is 7x minus 4. We would call these the diagonals of the rectangle, wouldn't we, everybody? And the diagonals of a rectangle are congruent. So 6x plus 4 is the same length. It equals 7x minus 4. So that's how we solve for x on this one. The diagonals are congruent. Subtract 6x. Add 4, and we get x to equal 8. If it did say find the length of AC or find the length of BD, we would substitute 8 back in, but it just says find x. We found it. X equals 8. Let's take a look at this one. This time we're not talking about a segment, we're talking about the angle measures. So find the value of y. So I ask you this question, what is the relationship between this angle and this angle? Some people might say they're congruent, and that's not the right property that we're thinking about here. A couple different ways you could look at this. This triangle has 180 degrees in it, doesn't it? And it's a right triangle because angle B is 90 degrees. So this angle and this angle have to add up to equal 90. Because if there's 180 degrees in a triangle, which there is, 90 plus 90 makes 180. So these two angles are complementary. They add up to equal 90 degrees. So that's one way you could look at this. Another way you could look at this is, because it's a parallelogram, this right here, one diagonal creates two congruent triangles. So this 4y plus 4, its alternate interior angle is right up here. It's also congruent, 4y plus 4. And now these two angles together make 90. Bottom line, this plus this equals 90 degrees. And then let's solve. All right, 4y plus 4 plus y squared minus 1 equals 90 degrees. Let's solve for y, shall we? Here we go. We have y squared. We have this 4y. And then we have 4 and a negative 1 make plus 3 equals 90. So whenever you have a y squared or an x squared and you have a y, what we're going to need to do is we're going to need to get everything on one side of the equal sign. So I'm going to subtract 90 over here. And now I have y squared plus 4y minus 87 equals a 0. When you're solving these kind of problems, when there's three different terms, a squared term, a y term, and a constant term, what we should think of right here is we got to solve by factoring. So you don't have to write this down just yet, but right now you would start thinking to yourself, okay, I got to get y times y to get y squared, and factors of 87 to get you 4. Well, we could try to factor, but this one is just not factorable. So let's erase what I just wrote here. We cannot factor this one. So now your next go-to, if you can't factor something, is you should use the quadratic formula. That's another way that you could find x, or in our case, find y. So if there's a squared term and a constant term and a y raised to the first, what we want to do is we want to use the quadratic formula. So here we go. A negative b. Here's a, here's b, here's c. A negative 4 plus or minus the square root of b squared. So I should maybe define this. We're talking a is the coefficient in front of y squared, which is 1. B is the middle term. It'd be 4. And c is our constant term. It's a negative 87. So we have a negative b, a negative 4, plus or minus the square root of b squared. B squared is 4 squared, which is 16. Minus 4 times a is 1, times c, which is a negative 87, all over 2 times a. And 2 times 1 is 2. All right, let's continue solving. We're going to multiply all three of these together. So a negative 4 plus or minus the square root of 16. A negative 4 times 1 times a negative 87 is 384. All over 2. We add 16 plus 384, so it's a negative 4 plus or minus the square root. 16 plus 384 is 364. All over 2. Just about done here. We take the square root of 364. It's a decimal. Let's round to 2 decimal places. The square root of 364 is 19.08. A negative 4 plus or minus 19.08 all over 2. So we'll get 2 different answers for this. One answer is a negative 4 plus 19.08 divided by 2. And the other answer is a negative 4 minus 19.08 all over 2. All right, let's see. If we take a negative 4 plus 19.08 and then divide that by 2, we get 7.54. Y equals 7.54. The other answer, a negative 4 minus 19.08 divided by 2, is a negative 11.54. Y equals a negative 11.54. All right. Well, everybody, we can't have two answers for these, so let's go take a look and see which one it is. Take this negative 11, for example, negative 11 and a half. If I were to put a negative 11 in here for y, it'd be roughly a negative 44 plus 40. It'd be roughly a negative 40 degrees. Is there any such angle that's a negative 40 degrees? Not in a triangle. So this answer is not the one that we're looking for. Okay? This 7.54, if you were to put that in for y right here, and put that in for y right here, now we're looking at the triangle that would add up to equal 180 degrees. So 7.54 is our answer. So now taking a look at the converse of the diagonal property. We said earlier on in the notes that if a parallelogram is a rectangle, then the diagonals are congruent. Now let's bring this to the front and this to the back. That's what the converse is saying. So here's the converse. If the diagonals of a parallelogram are congruent, then it is a rectangle. Is the converse true? Yes, it is true. If the diagonals are congruent, then it is a rectangle. So if this is congruent to this, then these angles are 90 degrees. It is a rectangle. This is helpful to us because now if we have to prove if something is a rectangle or not, here's what we need to do. We need to show that the diagonals are congruent using the distance formula. Or what we could do is we could show the adjacent sides are perpendicular by using the slope formula. So we'll need both of those formulas again. So let's take a look here at this problem right here. Is this a rectangle? Well, we can't just know by graphing it. We have to do one of these two things. Show the diagonals are congruent or show the adjacent sides are perpendicular. Let's first put this on graph paper and see what we're looking at. A negative 2 up 1 is point A. B is right 4 up 3. C is 5, 0. And D is left 1 down 2. So is this a rectangle? You might say, yes, it is because it looks like it, or no, it's not because it doesn't look like it. You can't just say because of what it looks like. You got to use one of the two things that we talked about on this last slide. So let's first see if the diagonals are congruent. So let's find the distance from A to C. The distance from A to C equals the square root. So we're doing A to C. So the distance formula is subtract the x's and square them. 5 minus a minus 2 squared plus subtract the y's and square them. 0 minus 1 squared. 5 minus a minus 2 is 5 plus 2. 5 plus 2 is 7, and 7 squared is a rock solid 49. 0 minus 1 is 1, and 1 squared is 1. So what is the distance of segment AC? It's the square root of 50 units. Let us now see what the distance is from D to B. If that segment is the square root of 50, bang, we have a rectangle. Let's see what the distance is from B to D. So the distance from B to D equals the square root of x2 minus x1 squared, a negative 1 minus 4 quantity squared, plus y2 minus y1 quantity squared, a negative 2 minus 3 quantity squared. All right, -1 minus 4 is -5. Square -5, and we get 25. A -2 minus 3 is a -5. Squared is a positive 25. What are we seeing here, class? We're seeing that segment BD is also the square root of 50 units. If these two are the same, we have congruent diagonals. And if the diagonals are congruent, then yes, it is a rectangle. Isn't that something? So we just proved it's a rectangle by saying that the diagonals are congruent. Another thing you could do is you could find the slope of all four sides and see if the adjacent sides are perpendicular. So watch this. I'm not going to use the slope formula. I'm just going to count rise over run. From A to B, I have to go a rise of 2 and a run of 1, 2, 3, 4, 5, 6. A rise of 2 and a run of 6. 2/6 reduces to 1/3. How about from D to C? I have to go a rise of 2 and a run of 1, 2, 3, 4, 5, 6. 2/6, which reduces to 1/3. From B to C, I got to go a rise of a -3 and a run of 1. A -3 over 1. From A to D, I have to go a rise of a -1, 2, 3, and a run of 1. A -3 over 1. So if you didn't want to use the distance formula, you could say the slope from A to B is 1/3. What's the negative reciprocal of 1/3? A -3 over 1. So these two sides have perpendicular slopes, so that angle is 90 degrees. And how about from BC and DC? Those two sides are adjacent, and those slopes are perpendicular, 1/3 and a -3 over 1. So 90 degrees, 90 degrees, 90 degrees. You got to either use the slopes or use the distance formula. Let me know if you have any questions about that lesson when you get to class tomorrow.